Alright, all right. So welcome back to Mr. Levy's math room. Now, what we're going to be looking at, we're going to be looking at this multiple choice paper. It's the January 2023 math CSEC math paper. So we're going to look at some of the questions here. I may not get to go through all of them for this session, but we'll go through some of them definitely. Okay, so let's start. So we have for number one, what is the value of the digit 2? All right, so look at the value. And when we're answering our questions, we highlight, look for important points in the question. So in this case, they ask you, what is the value? So we want the value, right? The value of the digit 2, right? In the number, right? So, and this is it. So we're looking at this 2 here. Right, good. And that 2 is in the 100th place, all right? So it's in the 100th place. So it is saying we have 200th, all right? So 200th, so we have the 6 is in the 10th place. The 2 is in the 100th, and so on, all right? So our answer then would be A, 2 over 100, right? And if we were to write that as a decimal, it would be 0.02, all right? So, and that would be 200. Good. Now let's look at number 2. What percentage of 50 is 10? All right. So if we were to work it out, so you have 10, it would be 10 over 50. Now 10 over 50 would be what? Okay, let's do that. 10 over 50. And we're doing percentage, number percentage out of 100. So we do 10 out of 50 times 100. And 100, 100. Right? Now we can put the 100 over 1 to make them both fractions. All right, so we say 50 into itself is 1, all right? Then 50 into 100 into 100 is 2. Good. And then we say 10 times 2 is 20. So our answer will be 20. Now, if we know like the percentage, we know that 10%, so 10% of 50 would be 5. If you want to work it that way, 10% would be 5. 10% of 50 is, or what is 10? Okay, it's 5. What am I saying? So 10% of 50 is 5. So 20% of 50 would be 10. That's what I'm saying. All right, so our answer would be B. Good. Let's move this down. Okay. I'm not getting down. So let's just work on all the ones we are seeing here. Let me move this thing there. Good. So we have, let's go to number 6. If 4.3 times 0.37 equals 1.591, then 43 times 0.37 is what? Now notice what happens here. This is 4.3, all right? Now look at what they did. Multiply the 4.3 by 10. If you multiply the 4.3 by 10, you'd get 43. All right? So notice that the decimal point is moved one place to the right. All right? So in this case, you'd have 2 places of decimal. All right, so 2 places of decimal. All right, so now one other thing that we need to note when you're multiplying decimals we add the number, the number of digits behind the decimal point, and that gives us a number of decimal points in our results. So in this case, we are multiplying 4.3 times 0.37, and you get 1.591. Notice we have 1, 2, 3 digits behind the decimal point. So in your result, you will have 3 digits behind the decimal point, right? So the number of decimal point in the two numbers you're multiplying will tell you how many places of decimal you have behind the decimal point, or how many digits you have behind the decimal point in your result. Now in this case, right, we have 2 places of decimal, or 2 digits behind our decimal point in these two numbers. Now, if you notice, by elimination, we could eliminate A, right? So we could eliminate A because we have 1, 2, 3 digits behind decimal point, and it remains the same. And it couldn't remain the same as this here because it's now 43 instead of 4.3, so it could not remain the same. All right? So, and we are looking for a result with 2 decimal places in it. All right, so it could be B, but let's eliminate first. So when we go to C, C has only 1 digit behind decimal point, so it could not be C. All right, and D has 1 digit as well, so it's not D. All right, so we eliminate those, and if you notice, they move the decimal point 1 place to the right here. So obviously, we are going to move the decimal point in the answer 1 place to the right, all right, here, and that gives us 15.91. All right, so your answer is B. Good. Now let's look at this one. So, which of the following sets is defined by this? So, set X, these are the elements of set X. They say they fall between -2 and 4. All right, so let's read this. So this is saying X is greater than or equal to -2, X is less than or equal to 4. So the values, the range of values should be from -2 to +4. Now, once it says or equal to, it means that this -2 is included in your set, your solution set, and this 4 is also included in your solution set. So there are the boundaries, all right? So your least value should be -2, and your greatest value should be +4. Now let's look for that. So it cannot be A, because we don't have any -2 there. We should have -1, we should -2, and so on. It's not B, because we don't have the -1 and the -2. Not C, the -1, -2 and +4 is not there. And once it says or equal to, then it means that those values, these are the end values, all right? So the smallest, the greatest. Good? So your answer would be D. All right? So once it says, so, and this is how you read it. So you read it from X. So we say X is greater than or equal to -2, and X is less than or equal to 4. So that's your range of values. All right? Okay. Let's get the other questions. Let's see what is it. Just give me a sec. First time I'm doing this on Zoom. I generally just go into PowerPoint and do this. And so we're learning already. All right, there we go. Oh, but you see what is happening now. All right. Hold on, let me go back. You live and you learn. We're moving it. All right. I just ignore these marks. See if I can. No, but we need to go back to number. Right? Good. We will do number 5 and number 4. Okay. All right. Let me get rid of these. Just erase them. All right. Now let's look at number 3 while I fix all of this mess. Right. Okay. But you follow what I'm doing. All right. So just know the answers as we go along. So let's go to number. Let me get back my pen. Good. So number 3, which is all right. So number 3 says in standard notation, meaning standard form. For those who may not understand standard notation. So in standard form, 0.02086 is written as, so I want to write this in standard form. So we know a standard form is written as 2 power 1 point something times 10 to a power, right? So let me write this. So this is the standard. So it's A. Oh, it's disappearing. Hold on. Hold on. Let's see. Okay, let me see. This works. So we have appearing. All right, I'm not sure what to do to get it to stay, but we'll figure it out as we go along. All right? If somebody knows, you can just put it in the chat and I can learn it. All right. Let's try this. Let's see. But I want to write the general form for standard form. So it's A times 10 to the n. All right. So A times 10 to the n. So when you're writing a number in standard form, you can only have 1 digit to the left of the decimal point. All right. So that's what we say. So it would be a number point something. All right. So it has to be a number, one whole number point something. Good, times 10 to a particular power. So when we look at these, so we can eliminate, all right? And then we're not going to change the, okay, let me back up a little. So in this case, we only need 1 digit to the left of the decimal point. So in this case, we are going to move the decimal point to the right, all right? Until we get to a non-zero digit. Good? So move it till we get to a non-zero digit. So the number to the left of the decimal point when you're writing standard form, it cannot be 0. It has to be a number from 1 to 10. All right, from 1 to 9. All right, a number from 1 to 9. And so in this case, we are moving decimal point 1, 2 places to the right. Now the number of times we move the decimal point will tell us what the power is. All right. Now the direction in which you move the decimal point tells us what type of power. Is it a negative power or a positive power? So in this case, we are moving the decimal point to the right. If we are moving the decimal point to the right, that's a negative power, all right? So a movement to the right, the negative power. If we had moved the decimal point to the left, then we would have a positive power. But in this case, we are moving the decimal point to the right. We're moving it to the right, 1, 2 places, and so our power is going to be negative, all right? And so let's look for the what we have with a negative power. So it's not A, right? It's not B, but the powers are positive. And we move the decimal point 2 times, so it is not D either because that says 10 to the third power and it's positive. All right. So the only one there with a negative power is C. Good. So all of those we have to look at. All right. And then we determine our answer. So your answer is C. All right. Let's C. Don't know what's happening there. I'm going after this, I'm going to sign out, do my research and see how it works or what it should be. Good. All right. So in order for me to move the screen, I have to stop annotate. All right, I want to move the page up. So let me stop that. Then I move the page up. All right. Let's look at number 4. The number 4 says, in a school, the ratio of the number of pupils. So we look at that. Well, let me get by the pen. Move up a little more so that I can work through. Good. So I get this. Hold on, let me try that something there. All right. But I will get it for the next time. Okay, so in a school, the ratio of the number of pupils to the number of teachers is 20 to 1. Right? So the ratio of the number of pupils, so pupils first, right? So the number of teachers is 20 to 1. So it means you have 20 teachers to 1 student. You mean you have 20 students to 1 teacher. All right? So 20 students to 1 teacher. If the number of pupils is 840, how many teachers are there? All right, so listen, you have 20 students to 1 teacher. All right, and in the school you have 840 students. So how many teachers would we need? All right, so in this case, means we are going to divide 840. That's 840. Hold on. 40. Divided by 20. All right. Now, let's look at the answer. Now, common sense would tell us that if your answer could not be C and your answer could not be D, right? So the common sense just eliminate those. Those are just out of this world, right? They can't write, right? So you're either going to need 40 or 42, right? So let's do the because it's 20 students to 1 teacher, right? So let's do the calculation. So we cancel our zeros, and then we say 2 into 2 is 1, 2 into 8 is 4, right? And 2 into 4 is 2. So you need 42 teachers, right? you eliminate A. Now, to check if this answer is correct, what you can do, you can just multiply 42 by 20. Right? So if you say 2 4 is 8, 2 2 is 4, you add the 0, that's 840. Right? So a bag of apples can be shared equally among either 6, 10, or 15 children. Now look at what it says. A bag of apple can be shared. Right? So share the bag of apple. Right? And it says shared equally. Right? Among either 6, 10, or 15 children. So if you share it for 6 children, they're going to get equal amount. If you share it for 10, they're going to get equal amount. For 15, they're going to get equal amount. And they said the minimum, right? The minimum number of apples that is likely to be in the bag is, now when I said that you want to find the minimum number of apples that can be in the bag to be shared equally either among 6, 10, or 15 children, what do you think they're asking you to find? Good. They're asking you to find the LCM. You're smart. Right? So they want you to find the LCM, the least common multiple. Right? So what is the smallest number here that you can divide 6, 10, and 15 into without leaving a remainder? Right? So it's not 31. Right? And then let's try 30. So we're going to start with the smallest one. All right? So, and we say 6 can go into 30, right? How many times? 5 times. 10 can go into 30, 3 times. 15 can go into 30, 2 times, right? So if if you're going to share this for 6 persons, it means that each of them would get 5. If you're going to share the 30 for 10 people, it means each of them would get 3. And if you're going to share the 30 apples for 15 persons, it means that each of them would get 2, right? For 2 per, right? So that's the smallest one. That's the least. That's the minimum. We don't have to go any further than that. All right? Now let's hop across to number 8. The number of elements in the shaded region of the Venn diagram. Okay, we have to go back up. Okay, now I have to stop annotating. So until I get this thing right, wait, I will sort it out. I will get it. And if you get it before me, just tell me. Huh? Just let me know. Okay, so let me see if did we do number 7? Yes, we did. Okay. For number 8 is number 8. Item 8 refers to the following Venn diagram, which shows two intersecting sets, P and Q. In the Venn diagram, the number of elements in P, let me get back my pen. Right? Here, the red one came up here. Good. Okay, so let me see now. So it says the number sets P and Q, the number of elements in P, so this is P, so P has 5 elements. Good. And Q has 9. All right? So this is the Q here. All of this, sorry for my bad circle. All of this is Q. So Q taking, so it means that some of Q is in here, right? And then the same thing with P, it means that's P here, all of this. So it means that some of the elements in P fall in here as well, all right? So it means that's both, if they were, say, let's say they do math, so all the students in here would do both math or physics and whatever this would be, all right? So they share both sets. Good. But the total number in all of this is 5. The total number in Q is 9. So they say the number of elements in the shaded region of the Venn diagram is 5. So, and then they say the number in P union Q is 10. Right? Now P union Q means when we combine the elements of both sets is 10. Right? So between both sets, you have 10 now. If you notice, when you add 9 and 5, you get 14. Right? So that would surpass it to be more than this 10 here. Because, right? But the total number in both of them is 10. So it means that some of those 10 students overlap. Alright? So what we do, so we say the number in P plus the number in Q minus 10. Alright, so 9 and 5, 14 minus 10. Alright? That should be equal to 4. So that's your answer. Okay? Get to the next page. So that's it. So I'll have to erase all of these fandangles. Alright. Don't laugh at me. Okay. Alright, look at number 9. So it says, which of the following pairs of sets is an example of disjoint set? Now, a disjoint set, meaning that there are no common elements between two sets, all right? So they are disjointed. So if you were to draw a Venn diagram, there will be no overlap, right? So because there's nothing, none of the elements are common to both sets, all right? So let's take set A. So you have even numbers and odd numbers. Even and odd. Right? Do we have any even number that are also odd? No. Right? None of the even numbers are odd. So that would be a disjoint set. Okay? Let's look at B just to make sure. Multiples of 2 and the multiples of 3. Right? Are any of the multiples of 2 also multiples of 3? Yes, because let's take 6 for example. Right? Now 6 is a multiple of 2 and it's also a multiple of 3. So you'd have overlap taking place right there. Right? Now let's look at C, whole numbers and the rational numbers. Right? Those you have a lot of overlap, so you don't even look at that. Then you have multiples of 5 and multiples of 10. Now 10 is a multiple of 5 right there. Good? So it means you eliminate all of these right away. Good? So your answer would be A. Now I have to stop annotating again. Okay, let's read the question here first. So number 11, let's go to number 11. This refers to the following Venn diagram, which shows two intersecting sets. The number of students in each set is indicated. So there you have it. H has 5 and 2, 7, right? And V has 2 and 4. So that's 6, okay? And then there are 3 who are neither a part of hockey. Let's call them hockey and volleyball. So you have 3 students who are neither a part of, they don't play in the sport, if this was a sport thing. And then you have 2 students who play both sports. Right? So I have to stop annotating again, so I can move the page up. All right. So this is the question now. So U is the universal set, or the set represents students who play games. Okay. H represents students who play hockey. Oh, I was right. Hockey. V represents students who play volleyball. And the question is, how many students play either hockey or volleyball, but not both? Right? So they either play hockey or volleyball, but not both sports. So you don't want these who they say hockey or volleyball, so you don't want these outside of the Venn diagram, outside of the sporting section, all right? You don't want these 3 students because they're not playing no sport at all. They say students who play either hockey or volleyball, but not both. So here, these students play both, right? You don't want students who play either or, right? How many play either or? Good. I must annotate that. All right. Let's say they play either hockey or volleyball, but not both. Right? So you add these together, so you have 5 and 4 is 9. The answer would be 9. Not 6. You don't know how they get 6. Not 7. I'm not sure how they get the 7. I guess they add these 2. Right? And it's not 11. So 5 and 2 is 7. 5 and 2 is 7 and 4 11. Right? It's not 11. So it's 9. Good? Now let's go over to number 10. All students in a class play Scrabble or checkers or both. If 36% of the students play Scrabble only, and 16% of the students play both Scrabble and checkers. So 36 play Scrabble, 16% play both Scrabble and checkers. What percentage of students play checkers but not Scrabble? Okay, so let's go back. So all the students in a class play Scrabble or checkers or both. So 36% of the students play Scrabble only. We could just, let me draw a nice graphic Venn diagram, drawn to scale. And that. And let's call this Scrabble. And let's call that checkers. Right? Now we have 36% of the students play Scrabble only. Now this section right here represents Scrabble only. All right? Then it says 16% of the students play both Scrabble and checkers. So 16% play both. All right? So the question now says, I'm going to circle it. What percent played checkers, right? But not Scrabble, right? What percentage play checkers, but not Scrabble? So they want to find out this number of students who play Scrabble, who play checkers only, right? So we know that percentage out of 100, right? So we'd have said, we add what we know here at 36 and 16, and we subtract that from 100 because percent is out of 100, right? So it's 100 minus 36 plus 16, 6 to 12, that's 52, minus the 2, equal 48. All right? Good. So the number of students who played checkers only would be 48. But that's the entire set. Good. Right, so all the students in a class play either Scrabble or checkers or both. So everybody, the 100% of them play at least one of the sport. Good? That's what. All right. I'm going to do 2 more and then I'll have to run. I'll have to do the others in another session. All right. I'll have to run. Let me stop annotating. Come on, come on, come on, come on. Same 11. Let's do 12 and 13. Let me erase all of these undangles. Okay. Get my eraser and I'll splash them out. All right. And you can always let me know like what it is you want me to do, what it is you want me to go over, and I'll definitely do that for you. All right. So let's look at this. So we have the set of two digit positive integers that are divisible by 7 is an example of this is a lot of sets question. So the set of 2-digit positive integers. Now, integers, or say positive. So this is 2-digit positive integers. Integers are whole numbers, right? So to be all the whole numbers from 1 to infinity. Good. And then they say though the set of 2-digit positive integers that are divisible by 7. But in this case, note what it says here. Let me get my pen. Note what it says. It's a 2-digit, right? 2-digit positive integers. So this is key, right? So the set of 2-digit positive integers. So all of these numbers must be less than 100, right? So from 10 to 99 in this case, right? So remember I said the set of positive integers would be from 1 to infinity, and then the set of 2-digit positive integers. The 2-digit numbers would be from 10 to 99, right? And once you get to 100, you're going to 3 digits. You follow what I'm saying? All right, so, and Is there do we have a maximum? Yes, we do have a maximum. So it will be from 10 to 99. All right? From 10 to 99. All right. So that you have your range of positive two-digit integers. All right? And they say, question now is that instead of two-digit positive integers that are divisible by 7, and that is an example of what's it. So you want all of the numbers in here from between 10 and 99 that can be divided by 7, right? No, is that infinite? No, we can count them, right? And once you can count them, then that is finite, right? A finite means that we have a limit, we can count it, right? So it would be an example of a finite set, right? Okay. Now for every $100 sales or part thereof, a salesman is paid $10 as commission. Now, commission is pay you get on top of your regular base fee. I used to have like a flat rate, and then the commission now depend on what you sell. So if you sell, like in this case, let's say for every $100 sale or part of the $100, a salesman is paid $10, right? As commission. If his sales for a particular month were $1,020, how much commission was he paid? So for every $100 or part of the $100, he gets $10. For every $100 worth of something he sell, he gets $10 out of it. Do you follow what I'm saying? So in this case, our part of the $100. So if you sell $1, $2, $3, $4 only, then he's going to still get $10, right? All right. So in this case, you have 1,020. How many $100 can we get out of $1,000? Right? We can get 10. Right? 10 and $20 left. So 10 times 10 is 100. Right? 100 and then $20 left. And this is something say every $100 or parts thereof. Right? So the $1,000 or for the $1,000, you have $1,000 in that. So he would get $1,000. So for each $100, I mean each $100 out of those 10, you get $10. So that is $100, right? And then part of it now is the $20. For this $20 here, he gets so much money. Did you say $10? Very good. He get $10. Awesome. And then you add this $100 with this $10, you get $110. Great. So your answer would be, and then look at this now, students. You in terms of elimination, you eliminate that. Can be $10.20. Right? Because if for every $100 you sell over $1,000 worth of something. Right? It couldn't be this either. Right? Now this one they're trying to trick some person will choose this. Right? But your answer is definitely D. Alright? Let me stop annotating and go here. Now, I am very sorry I'm not able to go any further right now. I'll stop at number 13. Right? So in my next session, I'm going to be picking up at number, let me just erase that. I'm picking up at number 14. All right, I have to run. I have a meeting that I must attend to already. But what you can do, you can try to find the paper. Try to look for the paper. So let me just move the paper right through so it can be recorded. It can be recorded, so you can look at it, work through the other questions, and then when I return, I'll go through them. So you just work through them for yourselves, and then when we meet again, we can work through them. All right. So what I don't want to do is just make sure you work through the question. So that's all right. So that is being recorded. And like I said, if there are any challenges that you have, you can let me know and I'll try to work through as best as I can. All right, I'm going to stop right here and you can work through the others. All right. So bless you. And as usual, make sure you subscribe to my channel, Mr. Levy's Math Room. Subscribe, turn on the notification bell so you never miss another lesson. And make sure you share the video with your friends. All right. And for law school students, I am encouraging you. See, a lot of the things that we are doing on this multiple choice paper, you realize where they're coming from, first, third form. All right? First or third form. So they are important. And that's what we spoke about some time ago, that whatever you're learning in first form is to form your foundation, your base. All right? So don't think what the math you're doing in first form is just a first or second or third form. Right? You must have a proper base. All right, so bless you much. I'll see you in our next session. All right, you take care of your lovely self.